Hello students and welcome to my channel Maths Hub. So today in this video, I'll tell you about the inverse Laplace transform of derivatives. So far we have covered the standard Laplace transform, few formulas for calculating the standard values. Then we have done the linearity property, we have done the first shifting property, then we have done the change of scale property, and we have done multiplication by t and the derivative formulas, right? So let us see what is the inverse Laplace transform for derivatives. So we have done in the previous video that if we have Laplace of ft as f of s, then if we multiply ft with t to the power n, then what happens? We get minus 1 raised to power n, nth derivative of Laplace of ft, right? So nth derivative of the function fs. So now what are we doing? If I put n equal to 1, I'll get Laplace of ft is minus 1 raised to power n, minus 1 raised to power 1 in fact, first derivative of fs, right? So if I have to calculate the inverse Laplace transform for derivative, it will become Laplace inverse of d by ds of fs is minus t into ft. So this minus sign will go here and it will become minus t ft. So let us try to see a question on this. We need to calculate the Laplace inverse of 2s upon s square plus 1 whole square. So let us assume ft to be 1 by s square plus 1. So let us see first of all what is f dash t. What will be f dash t? It will be s square plus 1 minus 1 multiplied by s square plus 1 raised to power minus 2 into 2s. So that is becoming minus 2s upon s square plus 1 whole square, right? So it's a term similar to it. So if I use the derivative formula, we know that Laplace inverse of first derivative of fs, so d by ds of fs, that will become minus t into ft, right? So in this case, since it's not a function of t, I can say this is f of s and this is f dash s, right? So let us apply this formula. So Laplace of inverse Laplace of f dash s is minus t into ft, right? So Laplace inverse of f dash s. So this is my f dash s. So it is minus 2s upon s square plus 1 whole square. This is equal to minus t into ft. Now what is my ft? Ft is basically my function, right? So what will be my function in this case? Ft will be basically Laplace inverse of fs, isn't it? So Laplace inverse of what is my fs? Fs is 1 by s square plus 1. So 1 by s square plus 1 is what? Sin t. So this becomes minus t into sin t. So I can take this negative sign out. I'll get Laplace inverse of 2s upon s square plus 1 whole square is minus t st. So minus sign gets cancelled and we get Laplace inverse of 2s upon s square plus 1 whole square becomes equal to t into sin t. So what I basically did, whatever was given to me, from here I tried to identify what is fs function. So you can write this as capital Fs. So f of s is 1 by s square plus 1. So from there I can say that f dash s becomes, I've taken the derivative, it becomes minus 2s upon s square plus 1 whole square. So that serves my function. So I know that Laplace inverse of f dash s is minus t into ft. So I've taken the function f dash s as minus 2s upon s square plus 1 whole square. This is equal to minus t into ft. So I need to calculate ft. So ft is basically Laplace inverse of fs. So I calculated what is Laplace inverse of fs, that is sin t. I've substituted the value here. And from here, when I take out the minus sign common, I get Laplace inverse of 2s upon s square plus 1 whole square as t into sin, right? So So let us try to do one more problem on this. We need to calculate Laplace inverse of tan inverse 1 by s, right? So let us take the function fs to be tan inverse 1 by s, right? For tan inverse 1 by s, obviously we don't have any ready-made formula. So let us try to calculate what is f dash s. So f dash s will be 1 upon 1 plus 1 by s whole square multiplied by what is derivative of 1 by s? It is minus 1 by s square. So when you take the LCM, s square will move up, it will get cancelled, and this will become minus 1 upon s square plus 1, right? So we know that Laplace inverse of f dash s is minus t into ft, right? And what is basically ft? Ft is Laplace inverse of fs, right? So now Laplace inverse of, let us substitute the value of f dash s. It is minus 1 by s square plus 1. This is minus t. What is ft? Ft is Laplace inverse of fs, and I took fs to be my tan inverse 1 by s. So this is what I need to calculate, right? So now I can take out minus sign common. I have Laplace inverse of 1 by s square plus 1. This is equal to minus t into Laplace inverse of tan inverse 1 by s. So minus sign gets cancelled. What is Laplace inverse of 1 by s square plus 1? It is basically sine t. So I can divide by t, and that becomes my Laplace inverse of tan inverse 1 by s, right? So this becomes my answer. Done? Okay. So now let us move to the next question. So we need to find out the Laplace inverse of cot inverse 1 upon 1 plus s. So again, let us take fs function to be cot inverse 1 plus s. So what is f dash s? Let us try to calculate. It is minus 1 upon 1 plus s whole square, and then derivative of 1 plus s is 1 only, right? So let us try to apply the formula for inverse Laplace of f dash s. So Laplace inverse of f dash s is minus t into ft, right? And what is ft basically? Ft is nothing but Laplace inverse of fs. Let's put in the values. So we have Laplace inverse of minus 1 upon 1 plus s whole square. This is equal to minus t into ft is Laplace inverse of cot inverse 1 plus s, right? So you can take this negative sign outside. This is Laplace inverse of 1 by, I can rearrange the terms and write it like this. This is equal to minus t into Laplace inverse of cot inverse s plus 1 or 1 plus s, right? Now here you can see that s is getting shifted to s plus 1, right? So if I don't shift it, it is 1 by s square plus 1. So Laplace inverse of 1 by s square plus 1 is basically sine t, isn't it? And when s is getting shifted to s plus 1, that means we are applying the first shifting property. So s gets shifted to s plus 1, that means using the first shifting property, inverse first shifting property, we multiply sine t function with e to the power minus t. This is equal to minus t into Laplace inverse of cot inverse s plus 1. So minus sign gets cancelled from both sides. So what is Laplace inverse of cot inverse 1 plus s or s plus 1? T gets divided and we get e to the power minus t sine t divided by, right? So this becomes my final answer. So I hope this is clear. Okay. Thank you so much for listening. So if you have any doubts, please let me know. And if you like the video, do hit the like button. And those of you who have not subscribed my channel, do subscribe my channel to get the latest updated video. Believe in yourself and you will be able to succeed. Thank you so much.